Java's Level 2 curriculum is where you stop writing scripts and start building real software. Classes that model the world through inheritance and polymorphism, the collections framework to store your data, generics to keep it type-safe, the streams API to process it elegantly, and exception handling patterns solid enough for production. We're covering 5 lessons back-to-back, in the order they build on each other, so let's get started. Every advanced Java feature builds on object-oriented programming, so we start there: inheritance, polymorphism, abstract classes, and interfaces. A subclass inherits everything from its superclass with extends, and its constructor must call the parent's constructor with super before anything else runs. Dog and cat both extend animal here, each overriding makesound with its own sound. Super lets a subclass reuse the parent's logic instead of duplicating it. Manager's calculatePay calls super.calculatePay to get the base salary, then just adds its own bonus on top, overriding without throwing away what the parent already does well. Store any dog or cat in a variable typed as animal, and Java still calls each object's own overridden method at runtime. That's dynamic dispatch. Loop over a mixed list and each entry speaks in its own voice, no if or else required. An abstract class can't be instantiated on its own, but it can mix finished methods with ones like area here that every subclass is forced to implement. Circle fills an area, and printArea, written once on shape, just works for it. Interfaces go further than abstract classes. A class can implement as many as it needs. Since Java 8, they can even carry default methods with real bodies, like greet here, plus static utility methods called write on the interface itself. Objects like employee and manager are useful alone, but real programs need to store many of them at once, which is exactly what Java's collections framework handles next. The collections framework gives you ready-made structures for lists, sets, and maps, each with real performance trade-offs worth knowing before you pick one. ArrayList is your default list, a resizable array underneath, so getting by index is fast. Linked list trades that for fast insertion and removal at both ends, and doubles as a stack or queue through Deque. HashSet gives you the fastest add and contains checks but no guaranteed order. TreeSet keeps everything sorted at all times, and linked HashSet remembers insertion order. Watch how the same 4 fruits come out differently depending which one you pick. Maps follow the same pattern: hashmap, treemap, linked hashmap, and Java actually builds its set types on top of map internally under the hood. Treemap keeps every entry sorted by key automatically, no extra sorting step required. One trap worth knowing: removing from a list while an enhanced for loop is running throws concurrent modification exception. Use an iterator's own remove method instead, or skip the ceremony entirely with the newer removeIf, which does the same job in one line. Comparable gives a class 1 natural ordering baked into compare2, like sorting employees by salary. Comparator lets you define orderings from outside the class instead, so you can sort the exact same list by name, by salary descending, or chain both together as a tiebreaker. Comparable and comparator both worked because employee was a fixed type, but what if you want one box class that works with strings, integers, or any type at all? That's what generics solve. Generics let one class or method work safely with many types, catching type mistakes at compile time instead of blowing up at runtime. Before generics, a general-purpose container had to store everything as object and cast it back by hand. That compiles fine, but put in a string, pull it out as an integer, and it blows up at runtime, exactly the bug generics prevent. Wrap that same idea in a generic class, and T becomes a placeholder the compiler fills in at the point of use. Box string only ever holds strings. Try to set an integer into it and the code simply won't compile, which is the whole point. A method can introduce its own type parameter too, independent of its class, handy for static utilities. First element here works on an array of any type at all, and the compiler infers T as string automatically when you call it with a string array. Sometimes a generic method needs to do more than store a value, like compare 2 of them. Bounding T with extends comparable T says T can be any type, as long as it knows how to compare itself, which is exactly what a generic max function needs. Wildcards describe a type you don't need to name. The shorthand is PEX, producer extends, consumer super. A method that only reads numbers out of a list should accept a list of extends number. One that only writes integers in should accept a list of superinteger. Generics keep your data type safe, but Java also has a whole toolkit for writing shorter, more expressive code around that data, lambdas and the streams API. Lambdas let you pass behavior around like a value, and the streams API turns filtering, transforming, and collecting data into a readable pipeline. Any interface with exactly one abstract method is a functional interface, and that single method is what a lambda implements. Calculator here just needs one operate method, so add and multiply can each be written as a short, unnamed block of logic instead of a full class. Java ships common shapes, so you rarely write your own. Function transforms a value, predicate answers yes or no, consumer does something with no result, supplier produces one out of thin air, and bifunction combines two values into a result. When a lambda does nothing but call an existing method, a method reference is shorter and clearer. Systemoutprintln becomes a consumer method reference, and sorting a list of names case insensitively is just string : compared to ignore case, no lambda arrow needed. A stream chains intermediate steps filter, map, sorted, and nothing actually runs until a terminal operation like collect triggers it. Here we keep only words longer than 4 letters, uppercase them, sort alphabetically, and collect the result into a list. Put it to work on real objects. Filter a list of employees down to high earners in engineering, sum every salary in one pass, or group names by department. 3 completely different questions answered with the same small set of stream operations. Streams make the happy path elegant, but real programs also fail, and level 2 finishes by making sure your error handling is just as solid as your data processing. We close with the exception patterns that separate hobby code from production code. Custom exceptions, chaining, and try with resources. Extend runtime exception for failures that represent a programming mistake callers aren't forced to handle, like withdrawing more money than an account holds. It reads like a built-in exception, but it's entirely your own type with a message that explains exactly what went wrong. Extend exception directly, not runtime exception, when callers must handle a failure, typically anything tied to an external resource like a file or a network call. Because submit declares throws invalid order exception, the compiler forces every caller to either catch it or pass the obligation along. When you catch one exception but need to throw a more meaningful one, pass the original in as the cause. That's exception chaining. GetCause on the new exception returns the original, and the printed stack trace shows both, linked with caused by. Any class implementing autoclosable single close method can be declared right inside a tries parentheses, and Java guarantees close runs automatically, success or failure, with no manual finally block needed. Declare more than one resource, and they close in the reverse order you declared them. One sharp edge worth knowing: if both the try block and a resource's close method throw, the try block's exception is the one that propagates, and the close failure gets attached to it as a suppressed exception instead of silently disappearing. That's the arc of Java Level 2 objects that model your domain, collections that store it, generics that keep it type safe, streams that process it, and exceptions that keep it resilient when things go wrong. Every example here comes straight from the Java Mastery Path Level 2 lessons. In the order we covered them. Links to all 5 are below if you want to slow down, run the code yourself, and work through the exercises.